Let's make a Flappy Bird kind of game using Unity engine with some juicy clean code. I don't want this to be make a game in 5 minutes or 10 minutes kind of video. We'll take our time with this so that we can practice keeping our code clean. Alright, to start off, we'll create a blank 2D project. I'll name mine Rocketfish. It'll make sense, probably. Then we'll import the sprites required. I have already created a sprite sheet in GIMP. You can download it along with the XCF files from the link in the description. Instead of the bird, I made a fish with a jetpack on it, sort of. It also contains all necessary sprites that we may use today, but you may use your own sprites instead. Let's just import this PNG image into our project. Make sure you select the sprite sheet and set the texture type to sprite. The sprite mode should be multiple because it contains multiple sprites. And you may choose to set compression to none if you are worried about performance. You should probably test this out for yourself. Then click on the sprite editor, go to slice, make sure the slicing is set to automatic, and then hit slice. This slices down the sprite sheet into individual sprites. If any of your sprites are not sliced, you can click and drag your mouse to create a slice manually. You may adjust each box with your mouse as well. When you're done, hit apply. You can see that the sprites are sliced successfully. So first up, let's create the player or the rocketfish. We'll create an empty game object and call it player. Let's then drag and drop the sprite into the scene and name it player sprite. Reset the transform and make the sprite a child of the player. We'll drag and drop this in the project to create a prefab. This hierarchy helps separate the logic from the animations, which is good for animated objects with some logic. Cool. Let's then set an aspect ratio. Go to the game window, click on free aspect. These are all landscape ratios, but we need it to be portrait style. So we'll create a new item, change the type to aspect ratio, which will be 9 on the X and 16 on the Y, and hit OK. We can now see that the camera has a different aspect ratio. Let's now work on the player. First, let's scale it down so it's about the right size. Let's change the background by selecting the camera and changing the background color by clicking the eyedropper and choosing this sky blue color here. Great. Let's also drag in this platform or water and place it appropriately. Nice. Now when it comes to the mechanics, we are at a crossroad right now. We can either move and jump the player, or we can choose not to and make the obstacles come to us. The first one is realistic, so it means we have to work more on the camera settings, making sure the physics is accurate and whatnot. The second path is basically creating the illusion that we are moving, which is time saving, and let's be honest, no one's gonna know. It will be our secret. Okay, let's make the player jump first. We'll create a C# script and call it jumper. For the player to jump, this needs to be a rigid body. So let's go to the prefab and add a rigid body 2D component. Let's also add a 2D collider since we are here. I'll choose a circle collider 2D because my character is circular. Edit the collider to match the sprite as close as possible. Back in jumper, we'll create a reference to rigid body 2D called RB2D. At start, we'll get the component of type rigid body 2D. We only need to create a simple public function called jump. And inside, we'll set the rigid body velocity to vector2.up multiplied by a jump force, which will be a serialized float at the top initialized to 1. Now, where do we call this jump function? We'll create another script. Let's call this player controller. Why are we doing this? Because it is best practice to separate input from logic, and also to separate different forms of logic into its own separate class. We'll be doing this a lot today, so be patient with that. First, let's create a reference to the jumper and get the component at start. There are better ways to do this. You may use interfaces or abstract classes and use inheritance and stuff to eliminate these direct references. But I want this video to be amateur friendly, so that's a no-no. Okay, for the input, inside update, we'll check if input.getMouseButton down 0, that is if we press the left mouse button, or if input.getKey down, which needs a key code, which we will cache and serialize at the top, call it jump button, and if that is true, we will call jumper.jump. It's as simple as that. So if we press the left mouse button or if we press the jump button on the keyboard, we jump. So let's add the player controller and jumper to the player. Set the jump force to 5 and jump button to spacebar. Now if we play, we can see that the player can jump on input. Sweet. Let's set up the animations. We'll go to Window, Animation to open up the animation window. I'll dock it here. Let's make sure to select the player sprite and then hit on Create. Let's call this Jump Animation and let's drag in the jumping sprite, the one with the fire. Let's create another clip. Call it Idle Animation and we'll drag the idle frame as well. Keep in mind that these are just single frame animations for now. You can improve them to your convenience. Because we selected the player sprite, it automatically added an animator component to it. It also created an animator controller on the project as well. Let's open it in the animator window by double clicking on it. We need to set the idle animation as the layer default state. And let's make a transition from idle to jump and another from jump back to idle. Let's create a parameter as well. It will be a bool. Let's call it isJumping. We'll add a condition to the transition to go from idle to jump when isJumping is true and from jump to idle when isJumping is false. Now in jumper, we'll create and get a reference to the animator component, call it animator. We'll create a boolean called isJumping and set it to true when we are jumping. We shall also set the animator parameter to true as well. For that, we need to create a constant string jump parameter and initialize it to isJumping. This should be of the same name as the parameter we created earlier. To set both of them back to false, we need the update function. We'll check if we are jumping and if the rigidBody.velocity.y is less than 0, that means if we are falling, we should go back to the idle animation. Cool, it works well. One thing I forgot to do while recording the video was to animate the ground tile. We should select the sprite and name it water or ground if you like. So if we want to loop this ground, we should tell Unity to tile it. To do that, on the sprite renderer, change the draw mode from simple to tiled. So this is going to treat it like a tiled sprite, okay? Which means Unity will redraw the sprite based on the dimensions of this game object. We'll also add a box collider 2D to this and set auto tiling to true. Now if we want to make this animation loop seamlessly, we should take advantage of this tiling. And now let's go to the animation window and make sure that the ground is selected, create an animation and call it water loop. To make it look seamless, we need to make sure that the animation starts at the first tile and ends at the beginning of the second tile. In this case, let's look at this one mark here. We need to animate this sprite until the second mark here reaches this approximate position. We can confirm that the tiling starts from somewhere around here by just looking at the pattern. So now let's hit record, make sure we are on frame 0 and move the sprite to the start. And then around 3 seconds later, or frame 180, let's move the sprite to the point where the second tile resembles the beginning frame. Like this. We also need to select both of these keyframes and right click both tangents and set this to linear to make it seamless. Just test this out and you may increase the time gap to reduce the speed. Now to create and spawn the pipes. We'll create an empty game object, call it pipe. We'll drag and drop the sprites and make transform adjustments. Once it looks good, duplicate it and put one on the other side as well. We'll parent these two to the empty and create a prefab. Let's create a game object that handles spawning, call it pipe spawner. We'll add a new component called spawn pipes. It will have a serialized game object pipe prefab. It will also contain a function called spawn, which takes in a vector3 for the position. And inside we will instantiate the prefab at the position and with rotation quaternion.identity, which means no rotation. We will store it to a game object and will destroy it after 10 seconds by using the destroy function. This will make sure it doesn't stay in the game for too long. Just to keep things tidy in the hierarchy, we'll create an empty pipe holder game object. We'll also create a serialized transform for it and assign it as the fourth argument while instantiation. This is going to parent the spawned instances to this transform when we spawn it. We'll spawn pipes at fixed intervals. We'll need a serialized float for spawn interval, a float for spawn timer delta, and a public static float for spawn speed multiplier. We shall create a simple timer in update like this. We'll check when delta becomes less than 0 and spawn it. For the position, we will set it to transform.position plus a random height value using the random.range function. We'll also set the delta back to spawn interval, and outside we'll decrease delta by time.deltaTime. So this makes it so that whatever is inside the if condition will be executed every spawn interval number of seconds. For platform movement, we'll create another script called moveAlongDirection, which will contain a vector3 direction and float speed. And it just translates it along the normalized direction in the specified speed. If you decided to introduce projectiles and stuff later on, you can still use the same class for movement. Add the component to the pipe prefab. Direction will be -1 on the x-axis and speed will be 2. You can see that the movement works. For the spawner, we will assign the prefab and the holder. The spawn height for me will be 2.32. Just test this one out. The spawn interval will be 2.5 and I will decrease the player jump force to 4.5. We'll also click on the water sprite and set the order in layer to -1. The player will have the order of 5, so it stays top of everything else. Let's also reset the Y position of the spawner and move it to somewhere right of the camera. This will be the position where the pipes will spawn. Nice! The game is looking good. Now, if you want to increase difficulty as you go, we will set the delta to spawn interval multiplied by 1 divided by spawn speed multiplier. You can then increase this multiplier via another script if you want to. Just make sure to initialize this to 1f and clamp it once it reaches a certain value if you don't want to break your game. Also, there's one more thing that I missed, that is to add the sun. This is purely for decoration. You may choose to skip this if you wish to. We'll add the sprite, name it sun, scale it down, position it wherever we want, and maybe even add the move along direction in the sun as well. Let's set the direction to -1 on the x and the speed to something slow like 0.05. Now you may notice that the sun is moving a little bit, just for the effects. Now you can have lots of fun with this. You could add a collision on the left for the sun and then maybe perhaps change it into nighttime when the sun leaves. But I'll leave that to you. Next we'll deal with collisions and player death. Let's go to the pipe prefab and add 2D colliders to it. To avoid any unnecessary jerkiness and rotation, set rigid body interpolation to interpolate or extrapolate. I will set mine to extrapolate and freeze the rotation on Z axis. For death, we'll create a new script called death on collision. Again, you may reuse this class for anything that you want to add in this game, or you may just export this script as a Unity package and use it across all of your projects. So we shall write on collision enter 2D. We will call a death function. For this example, we are going to set time.timescale to 0f. In other words, we shall freeze the game. Let's add this component to the player prefab and check it out. It works. Nice. Now let's add a player score. We will create a UI canvas and then create a text. Make sure to take advantage of TextMesh Pro. You'd then have to import TextMesh Pro Essentials. Let's set the text to 00. For the font, I downloaded AlphaSlab1 from Google Fonts, and let's import that font file. Make sure that the font files you download contains licenses and make sure to read it carefully before using it. We'll right click on it, create TextMesh Pro font asset, and now we can select that font asset for the text. Let's align this to the top by selecting this anchor preset and place it at the top by alt-clicking on the same preset. You may see that the canvas has a different aspect ratio. To fix that, firstly set UI scale mode on the canvas to scale with screen size and set the reference resolution to 1080 by 1920. For portrait dimensions, you need to make sure to match the height to full. We'll have to increase the font size, set overflow to overflow and wrapping to disabled. You may also change other settings to your liking. To trigger the scores, let's add an empty game object called score trigger, add a box collider 2D and set isTrigger to true. Edit the collider to fill the gap. We'll also have to add a tag. Let's call it score. Later on, if you want to introduce collectibles and stuff, you may add new tags for it as well. Make sure to add the tag for the score trigger. For the collecting behavior, we'll create a new C# script. Call it score update. It should contain a public static integer. Let's call it current score. Now, on trigger enter 2D, if collision.compareTag score will increment current score by 1. That's it. We'll also create another script, call it score text. We need to be using tmpro namespace to access TextMeshPro components. We'll create tmp underscore text or TextMeshPro text and call it text. At start, we'll get the component of type tmp underscore text, and on update, we'll set text.text equals score update dot current score, and we need to convert it to a string, so we'll add dot toString. Make sure to add score update component to the player prefab and we are good to go. Now the score updates every time we pass the trigger. Cool. And now let's create the game over screen with a restart button. Inside the canvas, let's create an empty, call it game over screen. We'll also add a TextMeshPro button, call it restart. Increase the width and height of the button and make it big enough. Let's get rid of this text and set the sprite to a replay sprite. Instead of positioning the button, let's actually position and align the parent game over screen empty instead. So I'll align this to bottom middle. You may choose one that looks good to you. I'll also add an offset to the Y position of the button as well. We'll be creating a new C# script. Trust me, this is going to be the final one for today. Call it game restart. We'll create a public function called restart game. We'll need to be using UnityEngine.SceneManagement namespace. And inside the function, we'll say sceneManager.loadScene. And we need to specify the current scene build index for it to restart the current scene. So we shall write sceneManager.getActiveScene.buildIndex. This function will now reload the current scene whenever it is called. Let's click on the button and add a non-click event. For the game object, we are going to reference the button itself, which means we need to add a game restart to the button. And then we can choose the class game restart and then call the function restart game. On the player, inside death on collision class, we need a reference to the game over screen, which will be a serialized field game object game over screen. On death function, we'll say gameOverScreen.setActive true. We need to set the game over screen in the inspector. Let's disable the game over screen in the beginning so that it doesn't appear at the start. Also in our restart game function, we need to set the time scale back to 1f and set current score back to 0. And phew, it works. One little thing that I added to this off screen is I added a little tilt to the rotation of the rocketfish when it jumps. To do that, I got the sprite transform, cached a vector3 for the Euler rotation, and then simply set it as the rotation while jumping and negating it when the player is falling. You can do that by using the quaternion.euler function, and I really like this subtle effect. And finally, it is done, my folks. Let me know what you think in the comments below. If you have made custom sprites, I would love to see screenshots of a game. You can send it to me by joining on the Discord server below. If you have any doubts, let me know as well. Subscribe for more juicy Unity stuff and take care. See ya. Bye bye.